Alright, welcome. Today we are going to talk about the use of calipers, and we've got two calipers here. One is a slide caliper and the other one is a dial caliper. So before we talk about how to read the caliper, we're going to talk about the three ways in which you can use it to measure a piece of steel or whatever you're measuring. So here you have the most commonly used surface, and that's for making outside measurements. If you look closely, you'll see that there's a small cutout here on the center. That's for measuring the edges of plates, and if you look at the end, the teeth are sharpened here for measuring something like this pen. We can measure the outside of it, and that'll give you a really accurate measurement because it can't rock back and forth, where in here it can rock a little bit. The reason for this small cutout is for measuring on the edges of plates. So if you look at a plate, this one's been sheared. I'm not sure that you can see it, but there's a small edge where it's been deformed from the shearing process. If you were measuring the thickness of a plate, you would push it in so that that deformation isn't measured because it's in that recessed section. The other measuring part of this is these two teeth over here. This is for making inside measurements. So, for example, if I wanted to measure the inside of this pen cap, I would place it inside and pull it until it's touching both edges, rock it back and forth, make sure that it's nice and tight. The last part is this piece on the bottom. This is for measuring depths of things. So let's say you had a drilled hole that didn't go all the way through a part. You would place this on top, drop that down to the bottom of the drilled hole, and that's the depth of the drilled hole. Whether you have a slide caliper, a digital caliper, or a dial caliper, typically those three measuring parts are the same, measuring surfaces. The length of the caliper, they come in many different lengths. These here are 6-inch calipers. You can get them in 8s, 10s, 12s, various lengths. Okay, so now we're going to look at reading a dial caliper. So I'm not going to show you a digital caliper. They're fairly straightforward. You look at the number and that's what it is. So we're going to look at a dial caliper. Something that's different when you're looking at measurements on a caliper versus a tape measure in imperial is that in imperial, in inches, it's just divided. So an inch is divided in half, so we have half an inch. That's divided in half, so we have a quarter inch. Quarter inch is divided in half, that's an eighth of an inch. An eighth of an inch divided in half is a 16th. And then a 32nd and a 64th. A dial caliper, or any caliper, is more like the metric system. So I'm not sure if you can see it, but we have an inch. Here there's 1 inch. It's broken down into thous, or 100,000ths of an inch. So this isn't broken in half and in half and in half. We have 10 increments that make up 1 inch. I'll try and get a better shot here. So we have 10 increments that make up 1 inch. So if we break this down, that's the 5 there is still half an inch. But we don't break that down in half, which would give us a quarter inch. You'll see that there's no quarter inch mark on here. It's broken down into 10 equal sections. So here we've got the 1, that's 100 thou, or 0.1 of an inch. And then we've got 0.2 of an inch, 0.3 of an inch. And you'll see as I spin this out that the dial spins, and there's 100 increments on there. So as I spin that around from 3 till 4, you'll see it's added 100 increments on the dial. So if I spun this dial out here, you can see that we're past the 1, so we're bigger than an inch. We're past the 4, but we're before the 5. And on the dial, we're at 41 to 43. So the measurement that we have here is 1.43 .443 inches. The dial caliper is fairly simple to use. Here we're right before the 8, so we don't have a full inch yet, so it's 0.77, and then we're 77567, so 0.777 of an inch. When you zero your dial caliper, you want to make sure that this is adjusted accordingly. So right now I'm out by 100,000ths of an inch, or 0.001 of an inch. So to adjust that, I can turn this knob and change that to adjust it to 0, but I also want to make sure that it's not reading that way because there's dirt on any of the surfaces or I haven't bent it in any way. You also don't want to slam this shut because it will change the measurements. You can see it's changing as I'm going. It's such a precise tool that any knocking it, dropping it, chips in these teeth will change the accuracy of the measurement. So that is how to read a dial caliper. Okay, so the last part of this is reading the slide caliper. So the slide caliper is just as accurate as the dial or the digital. However, much more economical. It's budget friendly. They're harder to break. They don't require batteries, but they are a little bit more difficult to read. So we're going to look again only at imperial right now. Imperial's on the top. We've got metric on the bottom. So this is a 6-inch caliper. You can see it goes out to 6 inches, 5, 4, 3, 2, 1. It's broken up. The first section of this is broken up the same as the dial caliper. So we've got 1 inch here, and then you can see each inch is broken up by 0.1 of an inch, 0.2, 0.3, 0.4, 5, 6, 7, 8, 9, and then 1 inch. Really where we're looking is where the 0 lines up. So if that 0 lined up perfectly with that 1, it's 1 inch. If it lined up perfectly with the 2, it's 2 inches. Now in between those graduations, we've got our decimal inches. So 0.1 of an inch, if that 0 lined up perfectly, that's 0.1 of an inch. So something that we're familiar with, let's say, is a half an inch. So if that lined up perfectly, the 0 lined up perfectly with that 5, that's half an inch. So if you can imagine my finger, it's a little bit wider than half an inch. The tricky part about the slide caliper is the increments in between, let's say, the 0.4 and the 0.5. If you look between the 0.4 and the 0.5, there are 3 lines in between there, and there's 25 increments on this slide. In between 0.4 and 0.5 is, let's just talk decimal inches, 0.400. If the 0 lined up on that first line, it's 0.425, and then 0.450, 0.475, and then we get to half an inch, it's 0.500. The tricky part is when it doesn't line up exactly on one of those measurements. So I'm just going to slide it out here, and I'm going to lock it so it doesn't move. So if you can see that 0, it lands between 0.450 and 0.475. So it hasn't lined up perfectly with one line. So we know that our measurement is going to be greater than 0.450. It's going to be less than 0.475. The tricky part is figuring out where exactly it is, and this is always up to a little bit of interpretation. So across the top of the slide caliper now, we've got 25 increments. So they represent 0.001 of an inch. So that's 0, 0.001, 0.002, 0.003, all the way up to 0.025. What you want to find, if the 0 hadn't lined up exactly with a mark below it, one of these marks is going to line up with one of these marks below it exactly. This has nothing to do with the main measurement. We've already figured out that the 0 is past 0.450 of an inch. So we're just going to add to that. So this is the confusing part, is that one of these is going to line up. It doesn't mean that's the measurement. It's what we're going to add to it. So if we look at all those increments, see how the 15 lines up really well with the line below it? We're not worried that it's lined up with 1.2 inches. It's just that it's, so you could almost imagine, don't look at the numbers there. We're just looking at the lines. See how the 15 lines up really well? This is the part that's open to interpretation. So if I look at it a little bit sideways, you know, it might look to me like the 14's lined up better, or the 16's lined up better. But as you look across those, you're going to notice that the 15 lines up really well. The 16's pretty good. 17's out by a bit, 18's out by more, 19's out by more. They slowly, those graduations get to be out by more and more. And if you go the other way, it's the same thing. So it looks to me like 15 lines up best. That's open to interpretation, but for the sake of this, we're going to say 15 is the best match with the number below it. So now we look back at the 0. It's 0.450 plus 0.0015. Sorry, 0.015. So our measurement is 0.465. That's what that is measuring, 0.465 of an inch. Let's try this one more time. We're just going to slide it out, and I'm going to try and make it so that it doesn't line up with anything. Okay, so we're above the 1, so we know we've got an inch. Okay, for reference, 2 fingers-ish. So we're above the 1. We're above the 0.1, above the 0.2, below the 0.3. So we got 1.2 inches. Then when we look closer in the graduations, we've got 1.25 of an inch. We're below 1.250 of an inch. But it doesn't line up exactly. So we know we're greater than 1.225 of an inch. If I look across here now, again, I've got to find the one that lines up best. The 15 is pretty close to 15 again, but it's not quite. The 16 to me this time looks like it's lined up the best. So it could be 17. You could argue 17. Well, maybe we'll go 17 because 18 is close too. So yeah, arguably 17 lines up the best there. So we'll say it's 17. So it's 1.225 plus 0.017. So if we're looking at the breakdown of those numbers, I'm going to grab a piece of paper just to kind of show you what I mean there. So it's 1.000. Then we add the 0.2, 0.200. Then we add the 25 thou plus 0.025. And then we add the 17 plus 0.017. So now I've got 2, bring up my 1, 4, 2.1, 1.242 inches. And that is how you read a slide caliper.